Okay, so today we cover this thing called 1.10a, and then that homework is going to be due on Monday. I will check the homework for 1.9 for the folks who weren't here super early today, but let's jump in here on page 100. At the top, we'll start with the objective. Chris? Thank you. Amy? Okay, so let's think about that before we do some math. We're going to think back to this morning. This morning, you put on some shocks, and then you put on some shoes, yes? When you go home at the end of the day, what are you going to do? Take off your shoes, and then take off your socks, yes? It's very natural. So I'm just going to write down something. Here is what you did this morning. You put on your socks, and then you put on your shoes. And when you want to undo that, again, it's really natural for you, but I think that this carries over into our algebra lesson today. What do we do first? We take off the shoes, and then take off the socks. So it's not enough to just undo the socks and the shoes business. You got to undo it in reverse order, yes? Socks and then shoes. When you undo, you have to undo everything in reverse order. So that's what we're talking about here with this all about order. Okay, let's try number one. Can we go to Morgan? Go ahead. Okay, so there's some blanks here. So this equation is more complicated than any equation that we have solved using algebra. Now, some of you guys are going to be able to zip through this and already know how to solve it. So bear with me if you are one of those zippy folks today. Let's imagine that we happen to already know the answer. You guys recognize down here in part C, like we write down some numeric equation and then we would do the check. So what I want to do is think about the check. Let's suppose that I just make up a number. I tell you that x equals 8 is the right answer. Suppose that I've done some work. X equals 8 is the answer. It's not, but we'll just play. What's the first thing that we would do to check whether or not x equals 8 is the answer? Yeah, we'd plug 8 in for the x, right? And so we'd have this equation, 25 equals, I'll put a question mark, 8 over 5 minus 10, right? That's the check that we would have to do. It's not equal, so I didn't get it right. But how would we verify? Well, what's the first thing you would do to the 8 if you were doing the arithmetic over here on the right? You'd divide it by 5, right? So the first thing we would do is divide by 5, yes? And once you've divided by 5, what would you do? You'd subtract 10. Subtract 10, yes? Okay, so then if we are going to undo all this stuff that we did, remember you do everything opposite but also in the reverse order. What do we do first? Add 10, and then multiply by 5. So that's what we write here in the blanks. We would add 10, and then we would multiply by 5. And I'm going to put something here that I really want folks to continue to write, and that's this phrase, to both sides. Make sure we're doing it to both sides of the equation. So we add 10 to both sides, multiply by 5 on both sides. Okay, so let's actually do the algebra now. We'll solve the equation in the blank space. I'm going to ask you to write the equation as it is, just to copy it down. What did we say we're doing first? Add 10 to both sides. So we're going to add 10 down here. We're going to add 10 here. Put a big equals line. I'm going to say this a couple of times, but I just want to point it out for the first time here today. I added 10 to both sides. When I say sides, I'm talking about the left-hand side of the equation and the right-hand side of the equation. how can you tell where the divider is between the left and right hand side? It's the equal sign. So when I say add 10 to both sides, I mean that equals thing had better be between the two 10s that you put in. It is a pretty common error, and it is wrong to do something like this. Say, okay, I'm going to add 10 there, and then I'm going to add 10 there. And all of a sudden, these two 10s are going on the right-hand side instead of one on each side. So we got to be really careful that we put that 10 on both sides of the equals. Come on back. There we go. Okay, and then we add over here, we get 35 equals x over 5. And what happens to that minus 10 and plus 10? It's gone. That was the point. So we just added 10 to both sides. What's next? Multiply by 5 on both sides. So let's write that here. Times 5 and times 5. I encourage you not to use x for multiplication. X is going to be in many of our equations. Okay, 5 times 35. Maybe you have to do it on the side. That's okay if you have to do it on the side. 175 equals, what happens over here? It's just x. That cancels. That's why we put it there. So x equals 175 is the answer. Okay. Now this whole business about writing the do list is not mandatory. If you can solve the problem without the do list, super. If you need the do list, then use it. But I'm actually hoping we can eventually graduate to not needing the do list at all. So I'd really long-term like to not see anybody using it because I want us to just be that good at solving multi-step equations like this. But if you want it, you use it here. And I think it can really help. You know, writing the do list down makes it very clear when you are undoing everything. Okay, all right, so I think that's good. We're not going to do the check here, but just move on to the next page. And there's some notes that you can look at later, everything written out, including the do list. And then there's an example problem written out as well. And the classwork starts on page 103. So we are going to come back together in a little bit, but see how far you guys can get in your groups in the classwork. Okay, so we're going to do this full class activity using these little toys that are on your tables called algebra blocks. And we're going to try to develop the idea of like terms. Now, let me just first say that I expect some of you might be annoyed at this moment and don't really feel like playing with blocks because it seems silly and beneath you. You might be right. But Sandy, my colleague who's taught this for many years, she taught it without algebra blocks for a long time, and a lot of folks wouldn't get the idea. But since she has been using the algebra blocks, just about everybody gets it the first time through. Put that away, please. So bear with me, even if it seems quite silly. All right, you have a box in front of you. There are a bunch of different shapes. There are only 2 of them that we're going to be using today. You're going to look for some green cubes. They are pretty small. So what I want everybody to do is grab a whole handful of those, put them out on the table. And then you're going to look for these orange things that we're going to call rods. They're not cubes, they're not real big, but they're kind of like rectangles in 3D. So we're looking for those things, these things here. So grab all those that you can. We'll get you some more. You guys find the orange rods? Yep. Okay, everybody has the rods and the cubes. Grab this guy. Okay, take one of these here. I'm like Robin Hood. I got to take from the rich and give to the poor. Okay, so here's the idea. The key to this thing is over here on the side. Each of those green cubes represents the number 1, all right? Each of those orange rods represents the variable x, okay? That's the key. Keep this in mind as we do this activity. So here's what I want you guys to do. This is a group activity, not an individual thing. What you're going to do is gather and save something that represents 2x plus 5. Can you guys find something that represents 2x plus 5? Gather it together and save it. Set it off to the side. Two x plus 5. 2x plus 5. Everybody have it? All right, but I want to see just one group of 2x plus 5 in the middle. Everybody have one group of 2x plus 5? That looks like a single x to me. That's an x and two more. You need really two x's.
What is the number 2? That's the number 2 times x. I thought you were right.
They don't have enough. Okay, everybody have 2x plus 5? 2x plus 5? Where is it? 2x plus 5. What do we have here? 2x plus 5. Super. Do we have it? 2x plus 5. 2x plus 5. And we have it here. Super. Next thing I want you guys to do is to gather and save. (3x plus 6). 3x plus 6. Separately. Keep those. Keep the ones that we've already got. Set them aside. Save them. Separately, we are building 3x plus 6. We have there 3x plus 6. Great. 3x plus 6. They have it. 3x plus 6. Great. 3x plus 6. Super. And over here, 3x plus 6. Okay. Next thing. All right. Here we go. One person at your table has touched these blocks less than anybody else at the table. Whoever that person is, take all that you have in those two piles, jumble them together, and push them in front of the person that has touched these blocks the least. So scramble them all up, push them to the person who has touched them the least. And the person that now has this whole collection in front of them, I want you to regroup them and tell me what they represent. What do you have in front of you? How many x's do you have in front of you? And how many cubes do you have in front of you? Okay, what do we have? How many x's? 5x. And how many of the green cubes? 11. So would you guys all agree 5x plus 11 is what's represented by that final thing? Yes? Yes? Okay. Can some brave soul come up here on the smartboard, write in 2 mathematical symbols to represent what we have just done? I've got a whole row of stuff with x's and numbers. Go ahead, Amy. We're looking for 2 symbols to put up there in that row of stuff that I wrote down. Just use your finger and write on the board. Amy's putting a plus sign there. And many equal signs over there. Do we see it? Amy says that 2x plus 5 plus 3x plus 6 is really 5x plus 11. Yes? Everyone agree with this? And it's obvious, right? I mean, you just group the orange things together and you group the green things together, and this is what it said. But the important thing is that at no time were you allowed to mush together the orange things and the green things. This 5x plus 11 is not the same as 16x, right? It's not 16x. It's not 16. It's not anything. The 5x and the 11, they're really completely separate creatures, and you can't mush them together. So what we're talking about here mathematically are something called like terms. So here were some examples of like terms that you guys dealt with. You had 2x, those were the 2 orange things, and you had 3x, and they were like terms, and when you added them together, you got 5 of them, 5x. Yes? And then other like terms were the 5 that we started with, and the 6 that we added together. They were all green cubes, and they were like terms, and we mushed them together and got 11 cubes, and that's it. Okay? So let's see if we can push all that together and try number 9, which is to solve this equation, which is way more complicated than the equations that we solved earlier today. Now forget we're going to do this together, so if you guys could just pause. I know there are speed demons that want to just go. You guys are like racehorses. Like I give you an equation, you're just like, oh, I got it, I'm ready. So first thing, I don't want to make a do list right now. It's way complicated. But what I do want to do is combine like terms using the ideas that we just discovered here with these blocks. So for example, I have a 7x. Are those is that 7 greens or 7 oranges? Those are 7 oranges. And where else do we see oranges on the left-hand side? There's 24. Any other oranges? Actually do this in red. It's close to orange. All right, orange there, and then minus 8x. Okay, so we're going to smush all those things together because they're all the same orange things. So 7 oranges plus 24 oranges is 31 oranges. But then you take away 8 of them, and we're left with 23 what? X, 23 of those orange rods. Yeah? Okay, and then I'll circle in green the things that we represented with green cubes. On the left-hand side, what do we see? There's a plus 6, and then a minus 4. So that's 6 green cubes, and then you take away 4 of them, and that leaves you with positive 2 of them, yeah? 2 green cubes. Equals. So go ahead and do the same thing on the right-hand side of the equation. Okay, where are my orange rods in this problem? There's the 10x, and then we take away 3x, and we get 7x, 7 of those rods. And then finally, the green cubes are plus 5 and plus 4. How many cubes do we have? 9 of them. Okay, so first of all, can we agree this equation is looking a whole lot more friendly than the original equation? So the first step when you have one of these quite complicated looking equations is to combine like terms. Combine all those green cubes together and combine those orange rods together. Next thing, this is still slightly different than the equations that you guys solved earlier today. And here's a fundamental difference. There's x's on both sides of the equation. Yes? On the left-hand side, I see 23x. On the right-hand side, 7x. None of the equations that you did today have x's on both sides. Take a quick look. Just verify real quick that the equations that you solved earlier today all have x on just the one side. Yeah? So here's something that mathematicians love to do. They love to turn something that they don't know exactly what to do with into something that they know how to do. If we can get it so that all the x's are on one side, then this problem will look like all the ones that you did earlier today, and you have a way to solve them, okay? So there isn't anything new other than to say the goal is to make it look like what the other ones look like, which is to say get the x's on both sides. Now this is really important. There are a bunch of natural things that you could do right now. You could subtract 2 from both sides, right? Great. You could subtract 9 from both sides, yeah? Good. You could subtract 23x from both sides, or you could subtract 7x from both sides. There are 4 perfectly natural things to do right now, right? Of those 4, 2 of them are kind of wasting time. And of the 2 that are useful to do, 1 of them is nicer than the other. So there's really only one really good choice. So here was the goal again. Get the x's to one side. If I subtract 2, well, that's going to get rid of this 2 here, but I'm still going to have x's on both sides, yeah? So that's not all that useful. If I subtract 9, okay, great, it'll cancel that, but still, x's on both sides. So don't focus on just randomly picking something to move. You want to really focus on moving the right thing. Subtracting 23x is going to be really good because that's going to get rid of this. And I will have only x's on the right-hand side, yes? Same thing with subtracting 7x from both sides. That will cancel this. So those are the 2 you want to pick from. Sarah? You said something about if I do this, what happens? Yeah, if you have to subtract over here, you'll have a negative number, which is totally fine.
If you subtract 9.
That's true, but we're focused on like which of the x ones we want to move. So if you subtract 7x from both sides, will you end up with positives or negatives, Obi? Positives. So that feels like the easiest choice because you can avoid bringing a negative in. So again, the focus is to get x's all on one side. And we'll do that by subtracting, which one was the nice one? It's the 7x. And if you really want to think about why that's the nice one, it's because it's the smaller one. We're subtracting the small one from the big one. Okay, 23 of those orange rods minus 7 of those orange rods is 16 of those rods plus 2 equals 9. And what's much nicer about this equation than the one that came right up above? This looks like the other ones. What's the characteristic that makes this like the other ones? It's the x's are on one side, right? Here there were x's on both sides. Now there's just x on the one side. So go ahead and solve that in the normal way. You have done your work as a mathematician. You turned a problem that you didn't quite know how to handle into one that you've seen before.